Hello, in this video I'm going to show you how to derive the Weirstrass substitution, also known as the tangent half-angle substitution. This is a substitution that makes it easier to integrate rational functions of trigonometric functions. So a rational function where the numerator and the denominator are some non-trivial combination of trig functions that is pretty hard to integrate. This transforms this rational function of trigonometric functions into a rational function composed of rational functions. That is to say that we change the trigonometric functions into rational functions, which historically are a lot easier to integrate. If we can do a bit of algebraic manipulation, we can probably do some partial fractions, or it might even be simpler than that. And so this technique substitutes these trigonometric functions in for rational functions and turns what would otherwise be extremely nasty integrals into ones that can be done quite trivially if you're willing to crunch the algebra. And so I'm going to go ahead and show you how to derive this substitution and where it comes from. The substitution is to let our parameter t equal the tangent of x over 2. And you might see now why we call it the tangent half-angle substitution. And so before I do anything more, let's actually draw out a triangle that represents what this is telling us. So if we have an angle x over 2, if t is the tangent of x over 2, that means the opposite side is t, the adjacent side is 1, and 1 plus t squared, square root of 1 plus t squared actually, is the hypotenuse. And so as a result, sine of x over 2 is equal to t over square root 1 plus t squared, and cosine x over 2 is equal to 1 over square root 1 plus t squared. Now let's take a look at what dt is going to become, because remember, we're using this to help us integrate, and so we need to find what dt is and get dx expressed in terms of dt. So dt is equal to secant squared of x over 2 times 1/2, because of the power rule, dx. And this might look like we've made it worse, but actually we can look at our little triangle diagram and realize that secant squared is just the reciprocal of cosine. And if cosine is 1 divided by the square root of 1 plus t squared, the reciprocal of cosine squared is just going to be 1 plus t squared. And so therefore dt is equal to 1 plus t squared times 1/2 dx. And getting dx by itself, we find that 2 dt divided by 1 plus t squared is equal to dx. So we found dx in terms of t. That's one part of our substitution. And now, without loss of generality, I'm going to show you what sine of x and cosine of x become with respect to the substitution. I say without loss of generality because every other trigonometric function can be expressed in terms of combinations of sine of x and cosine of x. And so if you're able to derive what sine of x and cosine of x are with respect to this t substitution, then you can find the rest of those functions just by doing a bit of manipulation. So let's see what is sine of x. I want to find out what sine of x is. Now we're going to use a couple of trig identities. We're going to use some clever tricks. So sine of x, I think we would all agree, is the same thing as sine of 2 times x over 2, right? And we know what sine of x over 2 is, so we're going to use the trigonometric identity for the double angle of sine. We know that the double angle of sine is 2 sine. Normally this would be x, but now we're making the portion of our half angle x over 2, not x. So 2 sine x over 2 cosine x over 2. This became this. And so now we can solve for sine of x in terms of these rational functions here. So sine of x is equal to 2. What's sine of x over 2? It's t over 1 plus t squared square root. And then cosine of x is 1 over square root 1 plus t squared. And so we get that sine of x expressed with respect to our Weirstrass substitution is just 2t over 1 plus t squared, because the square root is cancelled out in the denominator, And now, our cosine of x, well, let's actually move this over here. We're going to use another trig identity. We're going to use the double angle identity on cosine of x to find out what it is with respect to t. Cosine of x, same thing. Cosine of x is the same thing as cosine of 2 times x over 2. And there's multiple ways to express the double angle identity for cosine. We're going to use this expression because I think it's the easiest. This is equal to 1 minus 2 sine squared of x over 2. So this is 1 minus 2. What was sine of x over 2? It was t over square root of 1 plus t squared. We're squaring this, keep that in mind. And so this is equal to 1 minus 2 times t squared over 1 plus t squared. But let's clean this up a bit. We don't want sine of x to be a sum of terms. Let's try to make it one single term, one single fraction. And so let's rewrite this 1 as t squared plus 1 over t squared plus 1. And then minus 2t squared over 1 plus t squared. This is going to equal 1 minus t squared over 1 plus t squared. And this, in turn, is our cosine of x. So to recap, we derived what dx was in terms of our Weirstrass substitution. We derived what sine of x was in terms of our Weirstrass substitution. And finally, we derived what cosine of x is with respect to our Weirstrass substitution. And so now, any rational function of trigonometric functions, we can apply this substitution to, and we can simplify the integral, and we can integrate it without too much trouble. So, I hope this video is helpful, and that's it.